Okay. Now let me just share my screen. Okay. And I want to just make sure you have, let me just, okay. Can you see the schedule?
Yeah.
Yes, yes, it's
Okay.
February.
Now
Yeah,
you have a copy of this, right?
Yeah.
Okay.
yeah.
So we're starting right here, Thursday the 23rd,
Mhm.
and we go to May.
Yeah.
So your last classes will be the 11th. See, last day of Thursday class will be the, well, your last class, I'm sorry, will be, because you meet Monday and Thursday. So your last class would be the 15th of May. All right.
Mhm.
So
Let's look at
everybody
it.
has this, no
Yeah.
problem, right? So
Yeah.
those are the sessions. And remember, we have a spring break right here, 7 through 13, which means we won't meet on that Monday the 10th, and we won't meet on that Thursday the
Good, good.
13th.
Uh,
Okay.
So you said the last class would be May
The last class is May 15th.
15th. Okay.
All right. And then we have I think it's a short break, and then we go into our summer session. All right. Now let me just, did you look at the curriculum?
mhm.
The curriculum,
Okay.
I tried to look at it.
Okay. Let me do a new share. And I sent you a curriculum for the spring. All right. Do you see it?
I think let me see. I have here.
I have it on the screen. Can you see it? I'm sharing it.
Okay, you have something in front of the screen, right? What's this?
Spring 2023 course outline. Maureen, can you see it?
Yeah.
Okay.
I have a
So,
double screen. That's why I'm with Miss Becker's name there. I don't know why this
oh, you
happened.
can, well, it's really in the center, the way it's, well, it depends on how you have your
Okay, I see. I know
format.
what to do. It's moved
Yeah.
now.
Yeah. Just format the
Um, yeah, I
format
see
the
format of.
participants, format the participants so they're on the side.
Okay, let me
And then
see.
you
I
can
don't.
see the curriculum. Now we're
Okay,
starting
so
today
yeah,
with exponents and scientific notation. Well, we
yes,
won't get to
I see that.
scientific notation, but starting week 1, we're doing exponent scientific notation. And today we'll just do some exponent operations. All right. And you can go through the schedule, and if we find we don't complete something, this will be somewhat revised. So this is like a tentative outline of what we will be covering. Hopefully we'll get to, let's see if I had algebra in here. Spring break. Oh yeah, algebra. I hope we can get to
I'm looking
algebra.
at mine,
All right. Questions,
but
Mercedes?
yeah, I'm looking at mine, but I don't see. I see Monday, February 20th, but I don't. And below it, I see week two. I'm seeing week one, but not all of
Oh,
the.
let me go back.
Not
February,
on you. Not on
today's
you.
date. Do you see exponents and scientific notation?
Hold
Week
on,
1?
I'm looking at what you sent me, and I like week one have only Monday, no class, but the rest of it is
Oh, yes, yes, I revised it. Yeah, I did. Yeah, I
okay.
put Monday, no class, because classes started on Monday, but we, classes started for
Yeah, because
the
Monday, that's
Monday.
almost common
Next
line.
Monday is for the Monday class, but Thursday is the 23rd. So yes, I did have a revised one where I put Monday, I think, no class, and then Thursday, of course, you see this, right, Mercedes?
I don't see all that reading. I only see Monday, February 20th, no class. But below that, there's nothing else. Then I see week two. So unfortunately, that part that you
Well,
have on.
are you looking at college or GED? That's it too.
Oh, you're
You're
right.
looking at college, aren't you?
College. Yeah, yeah. Just
Yep, you got
realize it.
go back to
Realize.
the heading. It should say GED prep math,
Okay,
13
okay,
weeks.
okay. I
That's
can't.
because I sent two because you and Maureen uh,
Yeah, no,
are
I
in
see.
both classes, the GED prep
Yeah,
and the GED college math. So I sent you two, but I'm not going over the college now. That's for later. This is GED prep. So do you have that one, Mercedes?
I just go back in and I see February 23, exponent orientation, scientific
Yeah.
note.
Yeah, you
Yeah,
have it. You see
I
what
touched the
is here.
wrong button and
Oh,
go to.
okay. Yeah.
Yeah.
Okay.
Thank you
Because
so much.
remember, there's two curricula, and
Yeah.
for those with in both classes, you got two. Okay. So let's get started. Now, one thing I found that with the whiteboard, it's not so easy to read. When I send you the whiteboard copy, did you notice that?
Yes.
So what I want to try now, I'm trying something different. I'm using PowerPoint that I think is better. So let's go to new share and let me bring up the PowerPoint. Okay. Now, do you see the PowerPoint?
Where?
What's on the first screen?
What I'm seeing is GD math prep exponent spring term 23, 2023.
That's right. Okay. So that we call that like a slide, right? Now I have my exponent rules. That's on the second. Now we won't go through all of these today, but I want you to go through this. We will only get to the multiplying where you add the exponents. So we'll take them a rule at a time. So multiplying, add exponents. So when you're multiplying, it could be a variable like here, a to the m times a to the n. You add the two powers, right?
Okay.
Now, you know the difference between, okay, before I do that, let me just go here. Okay. Now, I want to make sure you can identify the parts of the exponential expression where a to the fifth, a is the base, 5 is the exponent, sometimes called the power. Any questions on that?
Can you please repeat?
A to the fifth power. The base is the A. The 5 is the exponent of power.
Okay.
All right. Now remember, a variable can be anything from A to Z. Here I have A. All right. Now, we could also have a number raised to a power. Here's 7 to the third power. 7 is the
The
base,
base.
and right, 3 is what, Maureen?
3 is the exponent or the power.
Okay. You could also put a coefficient in front of the base. So like 3s to the second. 3, the number in front of the variable, is a coefficient. S is the base, and 2 is the exponent. Now now let's see if, oh boy. Now I put here 4p to the fifth. Maureen, what is the 4?
Wait, hold on. You says what?
4p to the fifth, right here.
Oh, the fifth.
What is the 4?
The
The
four
number,
is the four is the base.
no,
No, the 4 is the coefficient.
that's right. The number in front of the variable p, that's
Mhm.
coefficient. What is p, Maureen?
P P is the base.
That's right. And what is the 5?
5 is um
You
the
said it.
exponent.
Yeah, exponent of power. Okay. Now, Mercedes, q to the third. What is the 3?
The 3 is the exponent. Well,
And what
well,
is the Q?
okay. The Q is the coefficient or the base. The Q.
I don't want it or. I want what it is, Mercedes. What is the Q?
The Q is the coefficient. The
No,
letter.
remember the coefficient is the number in front of the variable. The coefficient here is really 1. You don't have to write the 1. So what is the Q?
So the Q become the base.
That's right. Q is the base. Now, just to make sure you really understand this, let me just see if I can put another one here. Okay. Let's write 36 y to the 5th. Okay. Maureen, tell me what the coefficient, the base, and the power.
The coefficient is 36. The
Y-
base is y, and the 5 is the coefficient.
The 5 is what?
The exponent, sorry.
Exponent. Very good.
Yeah.
36 is the coefficient, y is the base, and 5 is the power. Okay, let's try another one. Okay. 3 z. Okay, Mercedes. Tell me the coefficient, the base, and the power.
3 coefficient.
Okay.
What's that after the coefficient? Is it
That's
the
a
A?
Z.
That's a
That's a
z.
Z.
That's the base, and the positive 2 is our exponent.
Does that look like a positive 2?
Our negative 2.
Negative 2, because exponents can be negative, right?
Yes.
And we'll later look at how we can convert those to positive. Okay. Now, let's just take another one. Uh, let's see. 9, 9, B. Okay. Maureen, what is the coefficient? What is the base? What is the power?
Okay, the coefficient is 99,
Very good.
and the base is b.
Very good.
But you don't got a you don't, yeah, that's all you have.
You don't see a power?
No.
No, you only got 99b.
It's got to have a power. What's the power, Mercedes?
You have no power there. Unless it's 0.
There's the power. 1.
Okay, that's 1.
When you
Oh,
don't see the power, it's a 1. If it
oh,
were
I
a
see.
0, I would have put a 0 there.
Oh,
Remember
Oh,
that, Maureen?
yeah.
Remember
okay.
that default power is the 1. So when you don't see a power, then it's raised to the first power, 1. Got it?
Yeah.
Okay.
Yeah, you'll see that a lot. You won't see a power and you put a 1, because if it were a 0, like for instance, if I had 2 n to the 0. All right, what's the power, Mercedes?
The power, you mean 99?
Right here. We finished the 99 right here.
Where are you?
What's the power?
Oh, that's 2. Oh, C.
What's the power?
C. I see 2NC. Is that what you written?
What do you see, Maureen? Maureen?
It look like
It's not
I
written.
guess it look like two n.
What is the power?
Oh, the power is it might zero.
Zero.
Oh,
Yeah.
it's
That's
almost
a zero.
but Miss Barbara, it's our little open, so it's look like C to me. I'm sorry.
No, it's closed. Well, let me write it again.
Yeah, it's closed on your side. What to me is like a
Oh,
you're right.
okay. All right.
Yeah,
What's the coefficient, Mercedes?
2,
What's the power?
0 now.
What's the power is zero. What's the base?
N.
N. Okay. Let me put another one here. Okay. Okay. 33 R. This is an R. Okay. Make this a little better. This is an R. Okay. Mercedes, what is the power?
Oh, the power is 0.
It's zero. What is the base?
The base is R.
And what is the coefficient?
3.
Okay. Let's try another one. S to the 9. Okay. What is the base, Maureen?
The base is S
And the power?
9.
9. Very good. Now, so now you know when you have an exponential expression, you could have a base and a power. You could have a coefficient, a base, and a power. All right.
Mm-hmm.
If you don't see a power, then it's a
The
1.
one.
That's the
Okay.
default.
Uh-huh.
Because if it were 0, I would have put a 0, like here and here.
Hmm.
Any questions on identifying the parts of exponential expressions?
So, Miss Barbara, you're saying that if like oh I see 5 and 9 to the power, uh, um, no, let's go back to 3 then. If
Which
I
which one are you looking at?
3 are
3R to the 0 right here?
yes, so
Okay,
I'm sure I get it good.
here we go,
So
right
the
here.
coefficient is really 3, while the
That's
base
right. That's the
is R.
coefficient, 3.
So if you did not put a 0 there and you say what's the exponent, we should simply say 1.
That's it. Very good, right? Base of R. And if I didn't put anything there, the power or exponent would be 1.
Got you.
Got it?
Yes, ma'am.
Any questions on identifying the parts of exponential expressions?
I don't
I,
think so. 'Cause I
I
can't
wanted,
remember.
Maureen, your question?
No, because I got my write down, so
Okay. All right. Remember, you'll be getting all of this at the end because we're recording and then it would be saved and all of the things we're going over you'll get at the end. So it will match the recording. But I wanted to get into this before we got into the first rule of exponents, and that's the multiplication. All right, let's go back here. So we'll do the multiplication, and notice here you add the two exponents. So I put here multiplying, add exponents. So we're only going to look at that rule, and then we'll look at the other rules later. Okay, now let's go here. Okay. All right. Now we did the practice. Well, no, let me do it. Let's do some more practice. Okay. Now let's do this. I want to put, okay. I want to put some more exponential expressions and just do some simple math with them. Okay. This is 2c to the 4th plus 3c to the 4th. Maureen, what is that equal to? If you're rounding paper, go to mute, please.
So we adding, right?
Okay, Maureen. What would be the answer for this one?
Okay. We adding or we multiplying?
Okay, what is this sign right here?
Plus.
Plus. What is plus?
Okay.
Addition, right?
So it will be 5,
Okay.
right?
Okay, so all right, let's just write what you're saying. You said 5. All right.
5 for the coefficient, right?
Mm-hmm.
Okay, there's C and C is C, right? And it will be C for the base.
Okay. C.
And 8 for the exponent.
Why 8? Why would it be 8, Maureen?
I add 4 and 4.
But adding exponents come with multiplication of
Exponent.
exponents.
I see.
So what would be the power on the C?
16.
What would you say, Mercedes?
The adding is multiplying.
What you mean for the exponent?
No, I'm asking you what
Oh,
would
I
be the
see.
power on the C? 5C what?
Um, that would be 16.
No, okay. Let me try this.
Probably
Am I
0.
am I
No,
multiply?
no, let me do this. Suppose you had 2x plus 3x. What's that equal to, Maureen?
2x plus 3x is 5x.
5x. So go back to the other one. What would this be? 5c to the what?
5c to the power 5.
Where are you getting a 5 from?
Okay, 3 and 2 is 5x.
1.
1.
No, it'd just be 5c. Let's go back up here. It'd just be 5c to the 4th.
Oh, I
Oh,
see.
you don't do nothing.
Yeah, just like 2x plus 3. You just, what are you
Oh,
doing? You
I
just
see.
add the exponents. I'm
Oh, I
sorry,
see.
add the
Oh, that
coefficients.
when it
Oh,
is
I see.
multiplication, you
This
add.
is addition. Now,
Oh,
But
this
when
is
it's
addition of exponential expressions. But when you adding exponential expressions and you have the same base and power, you just add the coefficients. Just like here, I said 2x plus 3x equals 5x. So 2c to the 4th plus 3c to the 4th is 5c to the 4th. Just add the 2
oh
plus the
yes,
3.
I remember
Got it?
now. Yeah, I remember.
That's why I put here, because I know you remember if you say 2 plus 3 is 5. 2x plus 3x, add the 2 and the 3, and then just repeat the variable.
oh, I see.
Got it?
Mm-hmm.
Questions? Now
Okay.
you wanted to add the powers, but remember, Maureen, this is an addition, not a multiplication. All right. See, that's the addition symbol, plus. If it were multiplication, then it would be our exponential rule of adding the powers. Got it?
Yeah,
Mm-hmm.
Miss Barbara, excuse me 1 minute, please.
Yes.
It's a quick bathroom. Thank you.
Okay. All right. Let's just take another one. Okay. 5 t plus 9 Maureen, what is that equal to?
14T.
Very good, 14T. Because the powers are default to 1, right? But you don't have to put the 1. Okay,
Mm-hmm.
let's take another one. 10 D to the third power minus 5D to the third power. What's that equal to, Maureen?
That is 5G to the third power.
Very good. All right. Because you just really doing the operation on the coefficient. Subtract the 5 from the 10, you get the 5, and then just repeat the power, the base and the power. Okay, I think we are okay on those. Now let's just do some multiplication. Okay, let's go to our first rule. Now, multiplying, we said, what do we do with the exponents, Maureen?
We add the exponents.
That's right. Now, you could have the same base.
I'm back, Miss Barbara.
Okay. Or you could have different base. Now, let's just take some examples where we multiplying and we have the same base, because there's a difference if the bases were different. Okay.
Mhm.
All right. So 2 to the fourth times 2 to the second. 2 is what? What part of the exponential expression, Maureen? What is the 2?
The 2 is the exponent.
No.
Mm.
Remember, we have base, coefficient, power. Which
Oh,
one is
yes.
the 2?
The 2 is the coefficient.
No. What is the 2? Remember, the coefficient
Oh,
is in front of a variable,
the 2
Maureen.
is the 2 is the base.
That's right. The 2 is the base.
Yeah.
So you have the same base. You have 2 to the fourth and you have 2 to the second. The base is 2. The
Mm.
base is 2 for 2 to the fourth.
Mm-hmm.
The base is 2 for 2 to the second. So
Uh-huh.
what's the rule? You add the exponent. So
Yeah.
you add the 4
4 and the
and
2
that's
and get
right.
6.
2 to the 6.
6.
That's right.
Yeah. Mm-hmm.
Okay, Maureen, take us through the next one. 3 to the third, there again, the same
Uh-huh.
base,
Uh-huh.
times 3 to the minus 4.
Uh-huh.
So what do we get?
So you get 3 to the base, and you subtract 3 from 41.
Well, you adding the power, so it's 3 plus a minus 4.
Uh-huh.
And what's 3? What do you do when you're adding unlike signs?
You subtract.
That's right. And the power is that of the bigger number. So 3
Yeah.
from 4 is a 1.
1.
The 4 is bigger, it has a negative. So that's
Negative.
a 3 to the minus 1.
1.
Right. Okay. Let's take another example here. I want you to do this one. Okay. Okay, this is 4 to the second power times 4 to the fifth power, we'll say. What's that equal to, Maureen?
Okay. That equals to 8 to the 7th power.
Where are you getting the 8 from, Maureen?
I mean 4.
4, that's right. Same base. So
47,
we
yeah,
just
47.
repeat the base
Yeah.
and add the powers.
Power,
So
yeah, 4 to the
2
7.
plus
5 to
5.
7.
That's right. That's equal to 4 to
2
the
to
7th.
7, yeah.
All right. All right. Let's take another one. 10 to the 3rd times 10 to the 9. What's that equal to, Maureen?
10 to the 12.
That's right. 10 to the 3 plus 9. And 3 plus 9 is equal to 12. Right. 10 to the 12. Okay, so now we doing the multiplying and we're using the same base. Let's try some other examples with the same base. All right. Same base, some more practice. Okay. All right, let's take let's see. Okay. Take 8 to the 4th times, let's see, times 8 to the minus 4. What is that equal to, Maureen?
8. I don't know. 8 to 1 or 0. I don't know.
Hmm?
It's 8.
Okay, add the power, so that would be what?
4
4 plus,
plus
uh,
minus 4.
that's right, minus 4. What is that equal to, Maureen?
0.
That's 0. You're right. So this would be equal to 8 to the 0 power. And we know any variable or number to the 0 power is equal to what?
1.
1. That's right. That's one of our exponent rules, but we'll just go through it right here. Any number of variable to the 0 power is 1. Now, we know this is true because 8 to the minus 4 is really 1 over 8 to the positive 4. And 8 to the 4th over 8 to the 4th is equal to 1. So that's the way you could prove it. All right. Now, let's take another one. Let's take one with a variable.
You there, Mercy?
Yeah,
Mercy?
she's on mute.
Oh yeah,
Mercy?
I'm right here.
Oh.
Okay. All right.
You want to try the next one?
I
Okay.
could try. Yes.
All right.
Okay.
All right. 13 to the 7th times 13 to the minus 8. What is that equal to, Mercedes?
Okay, that would equal to 13.
What's the power?
The power would be minus 1.
Minus 1. Very good. You added a plus 7 and a minus 8. You subtract, you get a 1, and the bigger number has the negative.
Yes.
13 to the minus 1. Okay. Now this is still same base. Let me take one with a variable. Okay. This is G to the 5th power times G to the 9th power. What's that equal to, Mercedes?
It would equal to G to the 14 power.
14th, that's right. 5 Add the powers, 5 plus 9, and that's equal to G to the 14th power. All right, so now you, with the same base, you just add the powers, right?
Yes.
Now let's just do a couple of more, and then we'll look at somewhere the base is different or the powers are different. Okay, so let's just try a couple of more. 5 to the second times 5 to the fourth. Maureen, what's that equal to?
5 to the 6 power.
5 to the 6th. Add the powers. Okay. Now let me just take one with a variable. Uh, okay. H to the 5th power times H to the minus 8 power. What's that equal to, Mercedes?
Okay, that is equal to H to the minus 3.
Very good. Minus 3. Minus 8 plus 5 subtracts to a 3, and the 3 is the negative because the bigger number is negative.
Yes.
All right. Now, it looks like you understand the multiplication. You add the exponents. This is for the same base, right? Now, let's go to when we have different bases. If you have different bases and different powers, all right?
Mhm.
Bases are different, the powers are different. What does this say? I want you to read this, Maureen.
You mean then an expression with
Yeah,
different
read it.
bases and when an expression with different bases and different powers are multiplied. Each expression is evaluated separately and then multiplied. It can be written mathematically as a to the n multiplied by b to the n equals a to the n quotation multiplied by b to the n.
I mean parentheses.
Yeah.
Okay, so if you have a to the n times b to the m. Now a is what? Base or power, Mercedes?
Base.
That's the base. N is what?
N is the exponent.
That's right, exponent. Now b to the m, what is the base?
B to the M is the base. Sorry. B is the base.
B is the base, and the power is what?
M. The
M.
power. Yes.
Yeah, okay. So now A and B are different, so the bases are different. N and M are different, so the powers are different. So what you do is you just break the A to the M, A to the N, do that one separate. That's why I said do them separate, and then B to the M. So with an example here, if you have 10 to the third times 7 to the second, you have to evaluate the 10 to the third. And 10 to the third is what? 10 times 10 times 10. That's 1,000. 7
Okay.
to the second is 7 times 7.
It's
And that's
49.
49. So the answer is 49,000. Any questions on that
Oh,
example?
okay. The answer would be 1,000 times. Oh, you got to use the 1,000 multiplied by 49.
Right. You take what it says, evaluate separately. The 10 to the third evaluates to 1,000. 10
Yeah.
times 10 times 10.
Yeah, I got
The
that.
7 to the second is 7 times 7, which is 49.
Right.
Answer 49,000.
1,000. Yes, got it.
Any questions on that?
No,
No.
miss.
No questions? Okay, so let me just put one here for you to try. This is, I'll leave it right here on this one. Okay, suppose you had, all right, 5 to the third times 2 to the fourth. I want you to do that one and tell me your answer.
Is 4.
I hope you have your calculators. You have your calculators?
Yes, miss.
Okay, because you can use your calculators.
Mhm.
Anybody got an answer?
Just a minute.
Yeah. Ouch.
My answer, my answer?
Yes,
500?
you said 500. Maureen, what
Yes.
did you get?
I get 125, right?
Okay, 5 times 5 times 5.
Yeah.
Yeah, that's, let me just put it here. Okay,
Oh, sorry. I made a mistake.
you found your error.
No, I just realized there's a 4 up there.
125.
Shut.
That's 125 times what, Maureen? What did you get? 2 to the fourth, Maureen.
2 to the 4, I got
16.
2 to the 4.
2 times 2
16.
times 2 times 2. Yeah,
Hey,
16, right?
Yeah.
And
yeah.
then when you multiply that, what did you get, Maureen?
Okay.
2000.
Using your calculator, right?
Yeah.
Okay, so what's your answer?
What the answer?
1.25. Okay. 1.25. 1, 6. Okay.
Maureen, you have your calculator?
Yeah.
So what's the answer?
I get 20,000.
No.
Are you using your calculator?
Yeah.
125 times 16, Maureen. What's in the calculator?
125.
Multiplied by 16. What do you
160.
see?
I know my calculator like they're working too good.
You have the scientific calculator?
Yeah.
So what's wrong with the calculator?
1.25.
Clear
Multiply.
it out, put 125, put the time sign, and then put 16 and then enter. What do you get?
I get 20,000.
No.
Wait, Mercedes,
But
go to
my calculator only showing me
Mercedes, go to
20.
mute. Mercedes, go to mute. When
Okay, I
you
will.
when I'm talking to one person, the other person should be mute. I shouldn't hear from 2 people. Okay, Maureen, you put 125
Multiply by
multiplication
1.
16,
Okay.
enter. What do you get?
Right? This no, I had one. I know this calculator like it's working good. Cause it's more all zeros.
Your calculator's not working?
It don't look so. So I
Okay,
say 125 multiply
times
1 6
16.
enter.
And
And
what do you
give me,
get?
give me all zeros right there.
When you put the 125
Yeah. 1
multiplication
6
symbol times
multiply by 1 6 enter.
enter, and
Yeah.
what do you get?
Give me all zeros right there.
You need to get the calculator checked out. Mercedes, unmute yourself. Tell me your answer.
2000.
2,000. That's your answer. That's what you should get.
These
Uh,
calculator, miss, will they expired after a while, or you need batteries?
Well, eventually you might need a battery, but I've had mine now for like 5 years and it's still working. So I don't know unless maybe it was next to something and lost power. Because I know mine and I have the TI, the one that's
Yeah, that's the same one.
suggested for the test.
I got that one
And
too.
yes, and yours is not working, Maureen?
It sound like that.
Yeah, you may need a battery. You may want to look at instructions for a battery. Okay. But these are very durable. Like I say, I've
Mm.
had mine over 5 years and I haven't had any problems with
Yeah,
it.
mine a very long time too. It said TI 230XS.
TI 30XS.
Yeah,
Yeah,
mm-hmm.
that's the one that they actually put on the GED
Yeah,
test.
they used to have another one, but now they bring this. This is the best.
Hmm. Okay. All right. Different bases, different powers practice. Let's continue. All right. Let me put another one here. Maureen, you may have, are you on your iPad?
No, I on my tab. I on my this laptop.
You're on your laptop. So try using your calculator on your phone.
Okay.
All right. Let me give you another one here. Okay. We use it. Now remember, different bases, different powers. Okay. So we have 4 to the third power times 8 to the second power. Now remember, you can put these in your calculator with the powers, right? Even though this is 4 times 4 times 4, you can put the actual number in the power in your calculator. Does everybody know how to do that?
I'll see if I remember.
Mercedes, you know how to do it, right?
I did it
Put
before,
in
but
there 4 and then put the upside down V and then you got the power. Okay. And that gives you the answer. And then you can multiply that times 8 to the second. Well, you know 8 to the second is what? Maureen, you use the calculator on your phone?
Okay.
Okay. Now 4 to the third is what? Maureen?
64. Oh, sorry.
Maureen? What's 4 times 4 times 4? That you can do without a calculator. What's 4 times 4 times 4, Maureen?
That like 4, 4, 16, 16.
4 times 4 is 16. What's 4 times 16? Meta math.
4, 4 is 16. 16 by 4.
4 times 10 plus 4 times 6. What is that?
Going on this calculator like now working.
On your phone? Your phone calculator not working?
4.
4 times 4 times 4.
256.
Maureen, 4 times 4 is what?
16.
What's 16 times 4?
Off.
16 times
64.
4? 64, okay.
Mm,
So 64. And what's 8 times 8?
64.
And what's 64 times 64? What is that equal to?
4096.
Yes, 4,096.
Yeah.
That what you got, Mercedes?
Yes, Miss Barbara.
Okay. So you know when you have different bases, different powers, you have to do what? What's the rule? Somebody want to repeat
Multiply
it
the
to me? What do
exponent.
you do when you have different bases and different powers?
You multiply the powers, the base.
You do what?
Multiply the base by the amount of power. Like 4 times 4 times.
Now tell me the rule. When you multiply exponential expressions and they have different bases and powers, what do you do? Just tell me in like one line, one sentence. Maureen, you know? Let's go back up here. I had you read it, remember? You
Yeah.
evaluate each one of them separately and then you multiply what you get.
Yeah.
Evaluate each expression separately and then multiply. That's what we did. We evaluated a 10 to the third, we got 1,000. Evaluated 7 to the second, got 49, and then we multiply. So when your expressions have different bases and different powers, what do? Evaluate each expression separately and multiply. One sentence. Got it?
Yes.
Okay. Okay. Let's just do one more here. Okay. Maureen, your calculator's working on your phone?
Yeah.
Okay. All right. I want you to do this one. Okay. 9 to the second times 6 to the fourth. Give me your answer.
Okay.
Now remember you can do the power in your, well, Maureen, you said your calculator's not working, so.
Can you repeat how you do that in the calculator again, Miss Barbara?
I'm sorry.
Can you repeat how you do get the power on the thing in? I did.
Okay,
I'm
you
not practicing
put
enough.
the 9 in your calculator, Mercedes.
Yes, I did.
Then press that little upside down V. You see
Okay.
it?
Yes.
Okay. And then put the power.
Okay. Got
And
it.
then what do you get?
I get 9 to the second power.
No, no, no. The 9 to the second, you don't have to do that because now what's 9 times 9?
That
That's
is,
math. 9 times 9.
don't think I remember.
Mercedes, what's 9 times 9?
9 times 9 is
81.
81.
81.
9981. Yes.
81. So that one I thought you probably knew from your 9 tables, right? 81.
Mm-hmm.
9 times 9 is 81. Now, Mercedes, put your 6 in your calculator. Press your upside down V and put the 4 as the power. And what do you get?
Okay, 1 sec. Let me try it. So you say put the 6 in the
Put the
calculator.
6,
Touch the
then
V.
press that upside down V,
Put my
and then
4.
put that 4, and then enter, and what do you get?
Oh, I get 1296.
That's it. Very good. That's good. That's
What I was
1296.
doing, Miss Barbara, I was touching the X with it with a 2 power on the
Okay.
left side.
Okay.
That's what I was doing.
Now, Maureen, what did you get for your answer? This is a 6. Okay. Maureen, what is your answer? Big number.
You mean the 4 by 6?
The 81 times 1296.
Oh,
81 times 1,296. What do you get? What's that answer? using the calculator on your phone.
$81.
Times 1,296.
Yeah. 81. Mm-hmm.
What, you get an answer?
Not yet. It's 86. No, 81.
81
81.
times
Times
1,296.
1,296 into
What is your answer?
this again. I think my phone want cleaning too. 81 multiply
Multiply by 1,296.
296 into. I get 104,976.
104
976.
976. That's correct. 104,976. Is that what you got, Mercedes?
Yes, Miss Barbara.
Very good. So now you know what you have to do when you have different bases and different powers. You don't add exponents. You only do that when your bases are the same. All right. When they're different and your powers are different, you've got to evaluate them. In other words, 2 to the 4 is 2 times 2 times 2 times 2. And then if you were multiplying that by 3 to the second, 3 times 3, and then multiply the results. You got it?
Mm-hmm.
Okay. Any questions on multiplying with different bases and different powers? Questions?
No, Miss. No, thank you.
Okay. All right. Now let's go to, let's see, go to another screen here. Now, this is multiplying add exponents practice. We went through that before, and I just want you to tell me what you get. Let's start with Maureen. 3 to the 5th times 3 to the 2nd. What is that equal to, Maureen?
3 to the 7th.
Okay. Add the exponents. Okay. That would be, let's see, 3 to the 7th. 5 plus 2. Okay, Mercedes, 2 to the minus 2 times 2 to the 4th. Base is the same. Add the exponents. What do you get?
So I'm gonna get two. The power gonna be minus 2.
A minus 2 and a plus 4 gives you what?
A minus 2 and a plus 2.
No, that's a 4.
Okay, minus 2 and the 4 give you
Minus 2
2 to the minus
plus 4. What's that equal to? Mercedes.
2 to the power minus 2.
A minus 2 and a plus 4, Mercedes, is what?
Minus 2.
When you add a negative 2 and a plus 4, you get what?
You take away. So you get the answer is minus
How are you
2.
getting a minus? The
You got the
biggest
plus.
number is
Oh,
plus.
sorry, pardon me. Plus 2, plus 2, plus
Plus
2.
2.
Two.
Careful
I
now.
forgot. I forgot
Just
if
think
you that
logically. You've
that
got more
4. Yes,
positive than negative, right?
yes, yes,
You
yes,
have
yes.
more positive than negative. So once you
I,
subtract, your sign is a plus.
yeah, I already know, but you just slipped me. Just slipped me. I know that
Okay,
4 is a bigger number.
got it?
Thank you.
All right. Now, Maureen,
Mm-hmm. Yeah.
use one with different base and different powers. What's the answer? 5 to the 3rd times 4 to the 2nd. What is your
Yeah.
answer?
5 to the 3rd is
What's 5 times 5 times 5?
125.
125. Very good. Mental math. What's 4 to the second? 4 times 4?
16.
16. What is that equal to?
2000.
Okay, we've got 125 times 16. And that is correct, 2000. So let's just put out 2000 here. So that's 2000. So when the bases are the same, just add the exponents. When the bases and powers are different, evaluate each exponential expression separate and then just add them. I'm sorry, multiply them. Once you evaluate them, then because this is multiplication. Any questions on the multiplying exponents? Anybody want to repeat the rule for me?
Evaluate.
Okay, let's take the first one. When you're multiplying exponents and the bases are the same, what do you do, Mercedes?
Hi, good afternoon,
Hello,
everyone.
hello, Chastity. How are you?
I'm okay. Thank you so much. I'm so sorry. I'm trying to get certified again. So I'm going to school again and I have a lot of homework to do and everything. But I'm going to be here whenever I can.
Okay, all right.
Okay.
I'm
Thank you
glad.
so much.
What are you getting certified in?
Well, my medical assistant certificates expired a long time ago. So in order for me to keep
Okay,
moving forward, I have to do that. So I'm doing it again, and there's a lot of homework to do.
I'm
And
sure it is.
now they included math in it, which is like
Oh
oh my god,
yes, math is gonna follow you. Chastity, math
and
is
it's
gonna
like
follow you.
it's not following, it's chasing me. So I'm like, oh my god. I actually,
Ah,
told them I had such a good tutor, and I said she's the greatest, and I feel like this professor here, she's teaching is like she's teaching like first grade
okay.
math.
Uh-huh.
And I said, okay, so that's good. She's starting there, and Miss Barbara also, she's like in like higher. So I'm like, I'm good right now.
Well,
But
good. Yeah, but the thing is with that certification, the math that they're doing is actually a lower level than what you're doing. So you
yes,
should do pretty good with that.
yes,
Yes.
exactly.
You
Thank you so
because
much, Miss
don't
Barbara.
you find it easier?
Yes, I
Yes,
do.
yes. Well, very
So
good. So you don't worry. You're gonna ace it. Okay.
yes, thank you so much. I'll
You're
be here. Okay.
welcome. You're welcome. Okay. All right. Now, so Mercedes, you want to repeat that rule again? When you multiplying exponents and the bases are the same, what do you do?
You're going to carry forward the base, but you're going to add the exponent.
Yeah, you just add the exponents like we did in this example right here.
Yes.
Base is a 3, so you just add the 5 and the 2 and you get a 7. Same thing was with the 2. Base is 2, add the exponents minus 2 and the 4 and you get 2 to the second. Now, Maureen, what's the rule when you have different bases, different powers? What's the rule?
You multiply.
Maureen, I didn't hear the rule. We're looking at this 5 to the third
Yeah.
times 4 to the second. Before you say, Chastity,
3
please
by 40.
wait just a minute. Chastity, rename yourself to your name. It just shows iPhone.
Okay, I will soon. Let
Okay,
me see how to
because
do that
that's
again.
important for the
Um,
1199. That's how they keep track of students on. Okay.
okay. I wanna I'm doing this program for free. If anyone is interested in doing anything like um they for free, they have a few programs. I will I don't know if put it on the chat.
Yeah, put the information in the chat.
For what?
What time
For
is
CNN?
class finishes? 4:30.
For what? For class for what? So pardon me.
This tutoring at what time it finishes? At four
Oh,
thirty, right, Miss?
no, it's
Four.
2 to 4.
Okay, so it's time. What time is it now? 3:14.
Three, three.
I put it up before 4 o'clock. I'm trying to get dressed and go out. I'm gonna go out right now.
Okay,
So,
but rename yourself now from
all right.
iPhone to Chastity.
I'm gonna send you the info. I'm just gonna put it in the chat, okay,
Okay,
guys?
good. Put it in
Okay.
the chat.
Any help you guys need, just let me know. I'm in a rush right now. I'm sorry. Bye.
Okay, that's okay.
Okay.
Bye-bye. All right. Okay, so Maureen, you were giving me the rule when you have different bases, different powers. What's the rule?
You multiply.
Evaluate.
You have an exponential expression times an exponential expression. Powers are different and bases are different. What do, Maureen?
You multiply the number.
Before you multiply, what do?
I can't remember.
Mercedes, what do?
You're going to evaluate um, the expression separately, then you multiply.
That's it. Very good. Maureen, you heard that? Repeat it again, Mercedes or Maureen.
Evaluated the expression separately, then you multiplied.
Yeah. See, 5 to the third, you evaluate that separately. 5 to the third, 5 times 5 times 5 is 125. 4 to the second is 4 times 4, and that's 16. And then you multiply 125 times 16 and get an answer of 2000. So Maureen, you understand now what you do, right?
Yeah.
You want to say it in words?
No, not right now.
No, Maureen, I want you to say it
I
right now. I want to make
can
sure you understand it.
How did my hair goes?
Different powers, different bases. Step 1, Maureen, is what?
But it has different power, different bases.
What's step number 1?
Let me see. Okay, I'm going to cover.
E. Evaluate each
Oh, yeah.
expression. E. That's
Oh,
stick.
X.
Evaluate each
Each
expression. And what's
expression.
step 2? There's it right there. What's step 2?
You multiply.
Multiply. That's it, Maureen. Evaluate E. Evaluate each expression and then multiply them. That's it. And we actually did that. So you see the example there. 5 to the third. Because remember, when you're raising something to a power, what are you doing? You're multiplying by that number of times. All right. And then you just multiply and then you have your results. Okay. Now I want to, okay, let me just, okay, let's do some more practice because I want to make sure you understand this before we leave this. All right. Okay. All right. Now let's go to a variable. All right. 2 A. Well, this was a little different from what I've done, but anyway, 2A to the second times 2A to the second. Now I'm giving you one now with coefficient, a variable, and a power, right?
Mhm.
What would be your answer, Mercedes?
Okay, my answer would be um 2A, and the power would be 4. Am I wrong?
Two.
Nothing. The power would be 2. No. Yes, 2. The answer would
Well,
be 2A to the 4th power.
2a to the fourth power.
Yeah, I'm wrong.
Okay, let me do this. Okay. Oh my goodness.
Oh, you're going somewhere else to make us
No, no, that's I think that's Chastity.
Cassidy, yeah, she black up
Yeah,
this.
Chastity is yeah,
went to the
she's
wrong
sharing
page.
the screen. I should have Miss Beckles should have had those screen sharing for everybody else. Cause she took over the screen.
Uh-oh.
Let's see if I can
Let me
Cassidy, you take over the screen.
let me text
yeah,
her. Maybe.
okay.
Back.
Yeah,
Yeah,
okay.
you come up there.
I tried to send it. I stopped it though, so I don't
Yeah,
know.
you
Go to
Miss
chat.
Beckles doesn't have it set up where everybody share. She have it set up where everybody share.
Okay, Miss Barbara, I'm gonna send it to you,
Okay.
and
All
you
right.
know,
I
I
see
have
it.
enough time right now, so I send it to you, and then you can send
Share
it
it.
to. Yes, I don't know.
Yeah,
Yeah.
okay.
All right, thank
Yeah.
you. Bye bye.
Okay.
Bye.
Let's see. Let's see. I hope I didn't lose it.
You're there.
You did. You got 2A to the power 2, multiply by 2A to the power 2.
Yes, back. It's back, Miss Barbara.
Let's see.
It's on the screen.
Okay,
Um,
can you
it's
see it?
back.
Okay.
Yeah.
Yeah.
Two. Okay. Yeah, because I know she. All right.
So I was saying,
I have to put the option where sharing is not allowed.
I will up.
Okay. Now, a to the second is the base A. So what is this equal to, Mercedes?
Well, I was doing the top one and the bottom one.
No, I want you to do this one right here.
Okay, that would be A to the 4th power for the answer.
Okay, add the powers 2 plus 2 equal A to the 4th. All right. Now, let's just take this one and I'll just put it, it's really 2A to the second times A to the second. All right. Okay. So A to the second time A to the second is A to the 4th. So that would be what? 2A to the 4th. Is that what you said, Mercedes?
Yes, miss.
Yeah. 2A to the 4th, because there you have the coefficient and the powers are the same.
Mhm.
All right. But if those coefficients were different, then of course it wouldn't, you could just do that. All right. But here you have coefficient, power, and base. Okay, let's take another one. 3, okay, to the 4th times 5 to the 2nd. Maureen, what is that equal to?
Okay, so that be
Now, this, you don't really need a calculator because you could 3 times 3 times 3 times 3 is what?
27. Oh, four
Times,
times.
yeah. So what's 3 to the 4th?
Oh,
3 times 3 times
81.
3 times 3 times 3.
81.
81. That's right. So that's what I'm saying. You didn't really need to calculate because it's 3 times 3 is 9 times 3 is 27 times 3 is 81. So this is 81. And what's 5 times 5?
25.
Okay. And multiply that out. What do you get?
81 by 25.
81 times 25. What's your
2020. 2025.
2025? Did you get that, Mercedes?
Yes, Miss Barbara.
Okay, 2025. Any questions on multiplying exponential expressions?
Oh, Miss, thank you.
No questions? Okay, if there are no questions, let's see. We will go to dividing. Now, the rule, let me go back to the top here. Go back to the rules. Okay, the exponential rules. Okay, all right. Now, what do we do when we divide exponents? What do we do, Mercedes? Mercedes, you're on mute.
I'm sorry. We multiply.
When, we're at the second rule,
Okay.
dividing,
Then you subtract.
we subtract. What do we subtract?
We are going to subtract the exponent.
This is a fraction, right? A to the
Yes.
m over a to the n.
Mhm.
So if it's a to the m minus n, we subtract the exponent of the denominator from the exponent of the numerator.
Yeah.
That's very important now, because if you could say from the denominator from the numerator, which would be incorrect. So m is the exponent of the numerator, n is the exponent of the denominator. So a to the m over a to the n is a to the m minus n. It's a subtraction. So
Yes.
remember the difference. Multiplying, you add; dividing, you subtract. So if you had r to the 8 over r to the 3, r to the 8 minus 3 is r to the 5th. Any questions on the dividing exponents of the rule? Because we're going to look at some examples. So everybody understands the rule, right?
So far, I'm trying.
Okay. All right. Well, we'll know when we start practicing. All right. Let me go down here to back to our slides. Go to the division. Okay, here we go. Now, dividing, subtract exponents. You see the examples? X to the 4th over X to the 2nd, X
Yes.
to the 4, numerator exponent, minus 2, the denominator exponent. 4 minus 2 is X to the 2nd. All right, now here's a number. These are numbers: 6 to the 3rd over 6 to the 2nd. 6 to the 3rd in the numerator, that's the 3, minus the 2, this is the denominator. 2 from 3 is 1. 6 to the 1, or just the number 6. Any questions on those examples?
I'm just looking at them. No, 6.
No, I'll leave it right there. Maureen, any questions on those examples? Subtract the exponent of the denominator from the exponent of the numerator.
Yes.
Numerator is the top expression, all right? Denominator is the bottom. And here I have it with the dash and the slash. So 6 to the third is numerator, 6 to the second is denominator. And remember we said the default power is 1. So when you don't see the exponent, it's a 1. So 6 to the 1 can just be written as the number 6. Got it? Okay.
So Miss
Yes, yes, Mercedes.
the answer to the six, you said six, the third power minus two.
Yeah, because you
Oh yeah.
subtract the exponent of the
Okay.
denominator from the exponent of the numerator. Numerator exponent is a 3. Denominator exponent is a 2. So 3 minus 2
Yeah,
is
I
1,
put one. So I
right?
can put one six to the one power or just six.
That's it. So when you see a number or a variable and it doesn't have an exponent, what is the default?
One.
1.
What?
That's right. Because most times you don't see the 1, but that's the default. Okay. Now let's look at when you have different bases. Now back. Okay. Let's see. Okay. Now here we had the same base, X and X, right? And here the same base, 6 and 6. So that rule that we went over applies when the bases are the same. Now, what happens when your bases are different? Okay, let's go here. Different bases. Here the base is what?
Six.
And what is it here, Mercedes?
Two.
Okay, so that's a 2, right? So if you have different bases, you've got to evaluate these bases, right?
Yeah.
6
Yeah.
divided by 2 is a 3,
3.
and 3 to the third. 3 times 3 times 3 is 9 times 3 or 27. Got it? So
Yeah.
when the bases are different, you have to apply the operation to the bases. 6 over 2 is 3, and then you have 3 to the third. Now, what if the bases are different and the powers are different? We just like we were with the multiplication. Evaluate each one and then divide. So 10 to the fourth is 10 times itself 4 times. 10 times 10 is what?
40.
10 times 10?
One, sorry, 100.
And 100 times 10 is what, Mercedes?
1,000
And 1,000 times 10,
is 10,000.
that's how we got to 10,000. And then 5 to the second is 5 times 5. What's 5 times
25.
5?
25.
And 10,000 over 25 is 400.
Okay, so you divide 25 into what, 10,000.
10,000. Yes.
So let me recap right here to make sure I got it.
Okay.
So when you see 10 to the fourth power over 5 to the second power, you 8, and you say 10 4 times, right?
10 to the fourth power.
And then
10 multiplied by itself 4 times.
yeah, and I get 10,000, and then 5 multiplied by itself 2 times, I get 25, then I divide.
That's right. That's right. But like, remember when we went through multiplication and when the bases were different and the powers were different, we evaluate them each separately. So the same thing here.
Yeah,
The
so
10
once
to
you
the
see
4. Go ahead,
once
Mercedes.
you see the it is different, you start to evaluate and you know if it's division or etc etc.
Right. Mhm.
Thank you.
So, okay. So this is, all right. Let's go. Any questions on division of exponents?
So far, none.
Questions? Different bases or same base? So what do you do when the bases are the same, Maureen, for division?
The bend is the same.
When the bases are the same and you're dividing exponential expressions, what's the rule?
You leave it the same way.
I'm sorry, what did you say?
Bend is the same base. You leave it the same way.
No, you didn't give me the rule. Dividing, subtract exponents, right? So
Mhm.
when the bases,
It's different.
No, the same, she says.
no, when the well, no, when the bases and powers are the same, what do you do? Let's see, let's go back up here. Okay. Well, when the bases are the same, the powers could be different, okay? But when the bases are the same, what do you do with the powers,
You
Maureen?
subtract.
You subtract. That's the rule. Division of exponents, you subtract the powers, the power of the denominator from the power of the numerator. All right.
Mhm.
Same thing here. This was a variable x. Here is a number. Still, you subtract the power of the denominator from the power of the numerator.
Mhm.
Okay. Just like with multiplication, we add, division, we subtract. Then when we went to, okay, different bases, what do? Just like with multiplication, where you evaluate each expression, do the same with the division. Evaluate each expression and then divide, okay?
Mhm.
The, with the same base, you just, if with the same power and your bases are different, you just evaluate the base. 6 over 2 is 3, and that's 3 to the third.
Mhm.
But if both the base and the power are different, like here, 10 is different from 5, 4 is different from 2,
Mhm.
powers differ, bases differ.
Mhm.
That's when you evaluate each expression separately and then divide. Just like with the multiplication, we evaluated each expression separately and multiplied. That's when the bases and powers are different.
So, Miss Barbara,
Yes.
what if the power are the same?
Well, with the powers the same, you just okay, here the powers are the same. So we have, if we have bases different, we have to do the bases, right?
Okay, okay. Let's just do the
Yeah, you just,
oh,
well, this is a base 6 and a
yeah,
base
yes,
2. So you
yeah,
divide the base 6 by the base 2 and you get a 3 and the power's the same. So it
yeah.
should be 3 to the
Okay,
third.
okay.
All right. But if you have, like here, base differ, power differ, evaluate each separately, and then divide. Just like with multiplication, we evaluated each separately and we multiplied. Got it?
Yes.
Now, let's go back to the rule just to be sure. Okay, let's go back to the rule. All the way back to the division. Okay, here we go. Right here. There is a division. Notice you have bases the same, just subtract, right?
Mhm.
Both bases are A, and you just subtract M minus N. Here, both bases are R, so it's just the power of 8 minus 3 of 5. Okay. Now, if these bases were different, then you've got to do the division of the bases and then subtract the powers. Got it?
Mhm.
Okay. That was that first example I gave you. All right. So let's go back. Now this becomes a lot clearer when you do them. Okay. Let's go back to division. Okay, the one we just did. Okay, so that's the one we just did with a different basis. Okay, different
Mhm.
basis, different basis for the first one. The second one is different basis and different powers.
Mhm.
Okay, so different basis, different basis, different basis, same power, different basis, different powers. That's when it's parallel to the multiplication rule where you evaluate each expression separately and then in this case divide, whereas with multiplication, you multiply. Any questions on dividing exponents?
Not for now, Miss Barbara.
Okay,
Thank you.
so then you ready to practice some, right? Okay, all right. 20 to the 100 divided by 20 to the 40th power. Maureen, what is the answer?
This is 20.
Same base, different powers. So what's the answer?
Okay, that's 20.
Okay, so that's 20. And we know we're subtracting. So what are we subtracting, Maureen?
40 from 100.
That's it. Very good. So that would be 100 minus 40. And what's that equal to, Maureen?
60.
Okay, so 20 to the 60th power. Mercedes, you okay?
Trying to see if I'm with her.
Same base, different powers, just subtract the power of the denominator from the power of the numerator. And here, 20 to 100 divided by 24, that's like putting 20 to 100 over 20 to the 40. That's another way of writing it. Of course, remember division can just be written in fractional form, or you could just put a division symbol. 20 to 100 divided by 20 is the 40 says 20 to 100, 20 to the 100 power divided by 20 to the 40th power. Got it?
Yes. So the answer for that one is 20 to the yes.
20 to the 60. Subtract the 40 from the 100, like Maureen said. You get 20 to the 60th. Okay, Mercedes, what's the answer to the second one? That's a variable, a to the 5th divided by a to the minus 4.
So the answer would be a to the minus 2.
What would it be?
A
Okay, so let
to
me
the
put here
min
a. And you said a to the what?
minus 2.
How are you getting a 2?
5 from 7 is.
This is a
There's a
4.
4.
That's a 4.
I beg your pardon. It looked like 7 to me. I'm sorry.
That's a 4.
Okay. So
So
that would be
this would be
1.
5. It would be 1, you said?
Yeah.
5 minus a minus 4. What's that, Mercedes?
That would be minus 9. 9 minus 9. A to the power minus 9.
Minus gives what?
Plus 9.
So what's the answer?
8 to the plus 9.
A to the 9. Watch your signs. Got it? A to the
I'm
9.
making an error now, because I said to
Yeah,
understand.
watch your signs because minus minus gives you plus. Okay.
Okay.
Maureen, what? Oh, a
One
question?
question. Yes,
Go ahead.
ma'am.
Go ahead, Mercedes.
What would make me not realize that it was a 2 minus? The 4 have a minus, but the 5 don't have any.
The 5 is a plus. Default is plus. But this minus right here is for the rule, right?
Yeah.
Subtract the exponents when you're dividing. That minus is for the rule of the division rule. This minus is the minus that's on this sign here.
Yeah.
I mean, this sign that's on this the A right here.
Okay.
Okay. The rule says subtract the exponent of the denominator from the exponent of the numerator. But the denominator exponent is a -4. That's why we put it in parentheses here, -4. This minus is for the subtraction. Got it?
So the 5 automatically become -2.
The 5 is a plus. It never becomes a minus. A to the 5th is
Can't
a to the
remember
plus.
why. I'm trying to remember why you changed it.
Why did you change the 5? You don't change the 5.
Not
It's
not
a,
the 5, the sign. If
well,
if it is a plus.
why would you change a to the 5th? That's plus to a to the -5.
No, no, no. That's not the question.
Okay, what's the question?
In the beginning of the writing, a
To the
to the
5th.
power, fifth power is is a plus there.
The a to the 5th.
Yeah.
Default is a plus, always.
So the
If,
5 is a default.
no. When you
Eh,
don't
eh,
see a sign,
Oh
Mercedes, the
yeah.
default is plus.
Okay. So what I'm trying to get back in my head is why when you come over to the answer now you say equal a to the 5. Yeah.
That's just right here. A to the 5, a to the 5
Mm-hmm.
minus, that's subtraction. And that's what you do with exponential expressions when you're dividing. So that minus is for subtraction. And then -4, that's the power of the denominator. So that's minus a -4. That's for that sign on the 4 right here.
Okay.
This is equivalent to this. This minus is equivalent to the subtracting, the rule.
Okay. Okay.
You got it?
Okay.
Numerator power minus denominator power. The numerator power is a +5.
Okay.
The denominator power is a -4. The minus here is subtracting the exponents.
Yeah.
Okay, so you have 5 for the power of the numerator minus the power of the denominator, which is a -4. Got it?
Okay.
Negative is plus, so 5 plus 4 is
Is
a
9.
to the 9th power.
Yeah.
Got it?
Okay.
Is that clear, Mercedes? I don't want to leave if it's not clear to you. That
Yeah,
clear?
I get it. I got it.
Okay. So now let's just take this one. Maureen, what would this one be? A to the 4th divided by 2 to the 2nd. Now notice you have bases are different.
Mm-hmm.
So what would that be?
I would say,
Bases are different and powers are different.
I would say, I don't know if I got it. I would say 28 is 4.
What?
I would divide the 2 by the 8. No,
Right.
No,
no,
powers are
powers.
different
Yeah.
and bases are different. That's when you've got to do the separate evaluations,
Subtraction. That means you got to
right?
multiply 8 4 times.
Yeah, and what's that equal to?
8 4 times is 8. Let's see. 8 4 times is
That's right. 8 times 8 times 8 times 8. What is that equal to, Mercedes? Maureen. What's the answer there? You're doing it
okay.
on your
I think I
phone?
make a mistake. Yeah. 4
Yes.
496, 4096.
Yeah, 4,096. Very good. And 2 times 2 is what, Maureen?
4.
I'm sorry, this is division. Okay, this is 4. And 4096 divided by 4 is what?
1024.
1024. Very good. Okay. Mercedes, is that what you got?
Yes, miss.
See how that rule parallels the multiplication? When the
Yeah.
when the bases are different and the powers are different, evaluate them separately and then divide. This is division symbol. Got it?
Yes, miss.
Okay. All right. So let's actually I wanna let's see, let me put it insert slide. I want to put
You say this, miss, at 4, Miss Barbara?
yes, it's from 2 to 4.
Okay.
Okay.
Right. Yeah.
Let's see. I just want to do another division, just a couple more divisions because it's about time to close. Let me just put in dividing. And what do you do when you're dividing? What do you do, mouse ladies? What operation?
When we divide and we subtract.
Subtract. That's right. Very good. Subtract exponents. Okay. Now let me just okay. Let me give you this one. Let's see. 3 to the third, and I'll just put it as a fraction, divided by 3 to the third. What is that answer, Maureen?
It's 3 to the third divided by what?
3 to the third.
Oh, I don't know.
Subtract the exponent of the numerator of the
That's
denominator from
40
the exponent of the numerator. So that means
because
that would be
3,
what? 3 to
3,
the what?
3 to the 0.
That's it. 3 to the 3 minus 3, and that's equal to 3 to the 0, which is equal to what, Maureen?
3.
3 to the 0?
I don't know. 3 to the 0 is what?
Any number of variables to the 0 power is equal to what? We call it the 0 rule. What is it?
Anything to power. So I don't know. 3 to, I don't
A-
know.
Any number to the zero power, that's the zero rule of exponents. What is it equal to, Maureen? Any number of variable to the zero power is equal to
It's
what?
3.
No. What is it, Mercedes? Mercedes, you're on mute.
Pardon me, Miss Barbara. 1.
1. Very good. Any number, Maureen, remember that, the zero rule. Any number of variable to the zero power is equal to 1.
Okay.
Got it?
Uh-huh.
Okay.
Mm.
All right, we're gonna do one more, and I want you to do this one. Let's see, let me put this here. I want you to take 5 to the third power divided by 4 to the fourth power. I want you to do that one and give me the answer.
Okay, that's 3 to the power 5 divided by 4 to the power 4.
Now notice you have different powers and different bases, right?
Yeah.
So what do you do, Mercedes? Different powers, different bases.
You're going to evaluate.
That's right. Evaluate each of the expressions separately and then divide. So do that. Anybody have an answer?
I'm doubting my answer. I don't know. My answer I got for the 5 I get 125.
Okay, so you got 125
And the
Divide.
and 4 times 4 times 4 times 4. 4 times except 4 times. You got what?
256.
Yep. What's the answer?
So I got 2.048.
125 divided by 256?
That's what my
Can't be
calculator.
1 point something. So got to be a fraction,
It's
a decimal.
125
It's
divided.
a 2.04.
125 divided by 256.
That's what I did.
And what do you get?
Oh, I turned the other way around.
That's right, because it's got to be less than 1.
Yeah, that's what I realized. 5, 6,
Maureen, what did you get?
0. Sorry, go ahead.
Maureen,
Okay, I divided the 125
by
divided
250,
by
256. And what did you
256.
get?
I get 0.488.
0 point. You have a decimal right there, right,
Yeah,
Maureen? 4,
0.828.
8. You can stop right there. We can
Okay.
stop right there because the other number is less than 5. So it's 0.488. That what you got, Mercedes?
Yes. Yes, Miss Barbara.
Okay. All right. Any questions on dividing exponential expressions or multiplying exponential expressions?
All we need to just remember, evaluate.
Yeah, whenever your powers and bases are different,
Different.
you evaluate each term separately, and if it's division, you divide the terms. You divide what you get. And if it's multiplication, you multiply them, right?
Yes,
Mm.
Miss Barbara.
Okay. So you did good today.
Thank you.
Now, of course, I'll be sending you a practice session, but your practice will just be on multiplication
Okay, Miss Barbara, can
only.
I ask a question?
Yes.
Not differing from it, but Chastity says she's doing this CNN. Is she saying she get free classes or something like that?
Yeah, she said free classes and she would put the information in the chat.
Yes,
And
that
then
um,
hopefully I can save the chat and then send you that information. If
Miss
not, I'll text Chastity and have her send it to me and then I'll send it to you.
That's what she said. She said she gonna send it to you, Miss Barbara.
Yes.
yeah,
Yeah. So she'll send it to me and I'll send it to you.
Miss
Hey guys,
are
Yes,
you
Chastity.
here?
I just sent it in a regular text
Yeah, I
message,
saw
I
it.
guess.
I saw your name popped up.
So yeah, that's I got it for free. So you know that